Welcome all. So in this session we are going to learn about force, that what is force, balanced and unbalanced force, Newton's first law of motion, inertia and types of inertia. So stay tuned. Now suppose there is a book lying on your table and you just want to move it. So your common sense will tell you either pull or push. Even lifting is also one type of pull. In short, apply some force upon it. So what is force? Pull and push acted on the body is force. Now you will say me, ma'am, there is a box lying in my home. Whenever I tried to pull, whenever I tried to push, but it didn't move. So now let us learn physics behind this. Now what we have learned, we know that force is pull and push acted on the body. And we know that force is a vector quantity. Now what does it mean? It means whenever we describe force, we need to mention two things. The magnitude of the force, that is how much force is going to be acted. And second, the direction of the force, that is in which force is going to be acted. Only saying 10 Newton force doesn't work. Here, Newton is the unit of the force. We count force in न्यूटन. ये हमने न्यूटन बाबा की याद में रखा है. Okay. So these two factors are important factors which decides the motion of the object. Now let us learn how it affects. Suppose two forces are equal in magnitude and opposite in direction, are applied on an object, then they cancel each other and the net force is 0. Now see, here two forces are applied. Okay, one force is applied from this direction and one force is applied from this direction. Both are of the same magnitude. Their magnitude is equal. So in such cases what happens? They cancel each other and the net force is 0 and the object doesn't move. Okay. Now take another example. Suppose here he is pulling this side by 10 Newton force and he is also pulling this side by 10 Newton force. Here also two forces equal in magnitude and opposite in direction are acted. So the net force is 0 and the object doesn't move. Such forces are called balanced force. Okay. Now suppose two forces are not equal in magnitude but opposite in direction are applied on an object, then what we do? We subtract that forces and the object moves in the direction of the force which has high magnitude. Now let us see. Here is an object and suppose here you are applying 10 Newton force from this side and from this side 5 Newton force is applied. Now when their magnitude is not equal, in such cases what we do? We subtract the forces. So 10 Newton minus 5 Newton. So we have net 5 Newton force which is acted in this direction. So the object will move in this direction. Okay. Now take one more example. Okay. Now two forces not equal in magnitude but applied in same direction. Okay, then in such cases what we do? We add the forces and the object moves in the direction of applied force. Now see, there is an object. Okay, one force you have applied of 10 Newton. Now again you have applied another force of 5 Newton in the same direction. In such cases we add these forces and now we have 15 Newton net force applied on this object and the object will move in this direction. Okay. And such forces are called unbalanced forces. Now come back to your problem. Okay. Now there is your object is lying on the floor. Now the object is not moving. It means that balanced force is acting on it. There are two forces which are balancing this. That is why the object is not moving. Now suppose I lift this box. Means what I did? I applied some unbalanced force. And now I left it from here. So what will happen? The object will come down. So the gravity is pulling down. The gravitational force acted upon it and the object came down. Okay. because of this unbalanced forces, the movement happen. Now you will ask, is gravity not acting upon this when it is rested? Yes, gravity is acted. Then why it is not getting pulled down at the center of the earth? Why it is not sinking? It means the object is not sinking. It means gravity is pulling it down. Then there must be one more force which is acting in the opposite direction and an equal magnitude. That force we call as a normal force. So normal force is a force which acts against the force of gravity and which is equal in magnitude. So let us, in this case, how much force is acting? So let us say the mass of the object is 5 kg. Now gravity is 9.8 meter per second square. For simplicity, take 10 meter per second square. So now force acting is 50 Newton. So 50 Newton, M into G we know that. So 50 Newton gravitational force is acting upon this in downward direction, and that much normal force is acting upon this object in upward direction. Now see, 50 Newton downward gravitational force, 50 Newton upward force. Now you are pushing this object with 15 Newton force. Now you will say, ma'am, there is an unbalanced force. Now the object should move in this direction. Then why the object is not moving? Because there is one more force of the same magnitude is applied. That force is called frictional force. And so all these forces are cancelling each other. So the net force is 0 and the object is not moving. Now you will say, if I apply 10 Newton force in this direction. Now 10 Newton force is less than this force of friction. Then the object should move in this direction. Then why the object is not moving if I applied less force? Now understand one thing. The force of friction only opposes the motion. It doesn't create any motion. Okay. So if you have applied some force, it opposite, says no to the motion. It doesn't create any motion. That is why the object doesn't move. Okay. And another thing, object always move in the direction of applied force. It doesn't happen you applied force in this direction and your object moved in this direction. Okay. That is why though you have applied less force than the force of friction, your object doesn't move. Okay. Now see, what you did, you just brought someone for your head. Now 50 Newton gravity is still acting, 50 Newton normal force is acting, and 15 Newton you are acting, you are applying force, 15 Newton friction is working. Now you have additional 3 Newton force. Okay, so now here when forces are acting in the same direction, we add the forces. So 15 plus 3, we have 18 Newton force in this direction. And when the forces are opposite, we have learned we subtract forces. So 18 minus 15, we have 3 Newton force in the right direction. So the net force is 3 Newton and the object will move in right direction. Okay. Now do one thought experiment. Okay, just for a minute, think that what I did, I made this force of friction 0. I made this road very smooth, or I just made this area very something. I did that and I made this friction 0. Now what will happen once you pushed this? The object will start moving with the same speed and in the same direction, until and unless the external force apply upon it, and that all that our Newton Baba has put into a statement which we call as a Newton's first law of motion. So what is Newton's first law? A stationary object on which no force is acting remains stationary, and an object in a motion continues to move in the same speed and same direction when no force is acting on the object. Okay. In other words, stationary object remains stationary and moving object remains in motion in the same speed and the same direction until and unless an external force acts upon it. And this tendency of an object tendency of an object to remain in a state of rest or in a state of motion is called inertia. In our daily language, we call it as a laziness. Okay. Every object which has mass has an inertia, has some laziness, and this depends upon mass. More mass, more laziness. So, stay healthy. There are three types of inertia. When inertia of state, this means object doesn't want to their state of rest. Inertia of motion, it means object doesn't want to change their state of motion. And inertia of direction, it means object doesn't want to change their direction. Okay. Now let us see one by one. Inertia of state of rest, it means object doesn't want to change their state of rest. So let us see this. Let us do a simple experiment. Take a glass of water. Okay. Take a cardboard. Put one coin on it and just apply force in this direction. So because of this force, the cardboard will fly in this direction, but the coin wants to be in a state of rest. It doesn't want to change its state of rest. So it will stay over here, but gravity is pulling down, so the coin will fall down in the glass. So this is one of the example of state of rest. Now let us see inertia of motion. In inertia of motion, you might have observed that when we are traveling in a bus, sometimes the driver applies brake and the bus stops. Okay, then what happens? We all are thrown in a head direction because we are in a state of motion, and suddenly when we start, our body want to be in a state of motion, and this is what we call as inertia of motion. One more example in our day-to-day life of this is our fan. In our home there is a fan. When we switch off the fan, it doesn't switch immediately. For some time it rotates and then it stops. So this is because of inertia of motion. Now there is one more inertia, which is inertia of direction. So inertia of direction, what happens? Suppose a car is coming in this direction. Okay. And suddenly when it takes turn from here, the people sitting in the car, they are thrown in this direction. So this is because of inertia of the direction. People sitting in the car, they are in a state of inertia. And when the car takes turn, they are thrown in this side. So this is because of the inertia of direction. Now coming to the end of the session, we have learned forces, balanced and unbalanced forces. What is force? Then Newton's first law of motion, inertia, and types of inertia. Now if you have not understood anything, you can mail us on this email ID, and stay tuned.